सभी को नमस्कार। मैं अमोल आप सबका अजीम प्रेमजी फाउंडेशन और आई वंडर टीम की तरफ से आज के इस वेबिनार में स्वागत करता हूं। शुरुआत में मैं कुछ आपको आई वंडर मैगजीन के बारे में बताना चाहूँगा। आई वंडर मैगजीन जो है ये खासकर साइंस टीचर्स के लिए बनाई गई है, जिसमें कि विज्ञान शिक्षा और विज्ञान कक्षा कक्ष से जुड़े हुए अनुभवों को साझा किया जाता है, जिसमें अलग अलग शिक्षकों द्वारा इन लेखों को लिखा जाता है। अगर आप भी विज्ञान शिक्षक हैं और आपके अनुभव दूसरे विज्ञान शिक्षकों के तक पहुंचाना चाहते हैं, तो आप हमें आपके अनुभव 100 शब्दों में लिखकर भेज सकते हैं। हमारा ईमेल है iwonder@apu.edu.in। आई वंडर मैगजीन जो है ये साल में 2 बार पब्लिश होती है और ये 3 भाषाओं में पब्लिश होती है, हिंदी, इंग्लिश और कन्नड़ा। अगर आप इस मैगजीन से जुड़े हुए अपडेट पाना चाहते हैं तो आप हमारे वेब पेज पर जाकर सब्सक्राइब कर सकते हैं। हमारे वेब पेज पर जाने के लिए आप गूगल से भी जा सकते हैं, जिसमें कि अजीम प्रेमजी यूनिवर्सिटी और आई वंडर मैगजीन इन कीवर्ड्स को डालकर आप सर्च कर सकते हैं। जब सब्सक्राइब कर लेंगे आप, तब आप इस वेबिनार से जुड़े हुए जानकारी भी हासिल कर सकते हैं। और साथ में अगर आपको इस मैगजीन की फ्री प्रिंट वर्जन चाहिए तो आप उसे भी पा सकते हैं। मैं आप सभी का एक बार और स्वागत करता हूं। जैसा कि आप जानते हैं कि आई वंडर मैगजीन जो है हर महीने के दूसरे बुधवार को इस वेबिनार का आयोजन करता है, और इस वेबिनार में जो लेख जिन लेखकों ने लिखे हैं इस मैगजीन में, उनसे चर्चा की जाती है। इसी कड़ी में आगे बढ़ते हुए आज हमारे साथ है आलोक और वरुणी। इन 2 लेखकों के लेख हमारी पत्रिका में दिसंबर 2021 में छपे थे और जून 2022 में छपे थे। दिसंबर 2021 में जो लेख छपा हुआ था उसका नाम था वेनिस नून, और जून 2022 में जो लेख छपा था वो था व्हाट डज योर शैडो ऑन द इक्विनॉक्स टेल यू। ये 2 काफी रोचक लेख इन दोनों ने लिखे हुए हैं, जिसमें कि दोपहर के बारे में एक वैज्ञानिक अवधारणा कैसे बनी है, और दूसरा ये कि किस तरीके से छोटे छोटे गतिविधियों को आयोजित करके हम इन कंसेप्ट्स को समझ सकते हैं कि कब दोपहर हुई है या कब इक्विनॉक्स है। तो थोड़ा इन दोनों के साथ आज की चर्चा हम यही करेंगे। इन 2 विषयों को लेके और थोड़ा गहराई से समझने की कोशिश करेंगे। आलोक है जो एक सॉफ्टवेयर डेवलपर है और साथ साथ में एक अमेचर एस्ट्रोनॉमर भी है, जो आर्यभट्ट फाउंडेशन से जुड़े हुए हैं। आर्यभट्ट फाउंडेशन भोपाल मध्य प्रदेश में स्थित है। वरुणी एक आउटरीच एसोसिएट है जो द इंस्टीट्यूट ऑफ मैथमेटिकल साइंस चेन्नई से जुड़ी हुई है। आलोक और वरुणी, थैंक यू फॉर ज्वाइनिंग अस।
थैंक यू।
थैंक्स।
सो जैसे आज की जो चर्चा होगी, आलोक और वरुणी, मैं थोड़ा सा बताना चाहूँगा हमारे जो दर्शक है, हमारे जो पाठक है, जो आज इस वेबिनार में हमसे जुड़े हुए हैं, कि आज की चर्चा की एक रूपरेखा, एक फॉर्मेट कैसा होगा। शुरुआत के 30 मिनट में आलोक और वरुणी से उनके लेखों के बारे में थोड़ी और गहराई से जानने की कोशिश करूंगा कि किन चीज़ों को ध्यान में रखते उन्होंने ये लेख लिखे थे। साथ में जो दर्शक हमारे साथ जुड़े हुए हैं इस लाइव वेबिनार में, वो अपने प्रतिक्रिया और अपने सवाल भी हमसे पूछ सकते हैं। अपनी प्रतिक्रिया और अपने सवाल वो अपने चैट बॉक्स में टाइप कर सकते हैं, जिसे मैं आलोक और वरुणी से भी शेयर करूंगा। तो जैसा मैंने कहा कि आप आपके सवाल हिंदी और इंग्लिश में भी पूछ सकते हैं, क्योंकि आज की जो संवाद होगा, आज की जो चर्चा होगी, वो हम हिंदी और इंग्लिश दोनों भाषाओं में करेंगे। तो Alok and Varuni, shall we start our discussion? So Varuni, the first question is for you from my side. For many of us, learning about astronomy and astronomical events is associated with the night sky, and your article focus on daytime observation, which we can made by ourselves. How did you choose to write these articles? What you are thinking, and what advantage do you see in a daytime astronomy at the school level?
So this is something that I have been kind of thinking about for a while, and I've been working with Alok as well as another colleague at HPCSC to write a couple of activities for student at a school level. I think daytime astronomy. There are various other experiments as well, but what we kind of focus on is shadows and what shadows can tell you. So, there are a couple of things that are very advantageous of this at the outset. So, first of all, if you've seen the two articles, for neither of them you need anything fancy. You just need, a sunny day, flat ground, and that's it, right? Maybe a measuring tape, but even that you can get away with, doing some sort of measure. So, the requirements are very low. Anyone can do it. So that's one thing that was very attractive about it. The other thing that is very nice about this is that you can, many people may have experienced shadows and sunlight, like, in terms of, if you live in the same house for a few years, you might have noticed that, the sunlight comes in from different windows at different times. So these are things that students might have already experienced or have some understanding, some experiential sort of understanding of. But what we try and do here is to take that experience and make it a bit more scientific. So, and we can make it scientific very easily, right? It just involves some measurements at regular times. So there's a lot of science in it while having a very low barrier. So this was something that I thought was very nice to bring to students sort of all over the country. And being in a tropical region, sun we have pretty much most of the time. So pretty much any student anywhere can access this, and that's all you need. So that was one of the things that initially attracted me to it. There are a few other deeper concepts in terms of pedagogy and things like that maybe we can come to once we go through the rest of the discussion. It will come out slowly, I think, and once you try it with your students, you'll also see a lot of other learnings that might come out. I don't know, Alok, do you want to add something? Because I mean, Alok has also been kind of working on this.
Yeah, so the main motivation for shadow related activities is basically timekeeping. If you think about the roots of science, like far back in history, so astronomy was born for the need of keeping time. So seasons kept changing, day, night, lengths kept changing. So shadows was one of the ways that our ancestors used to measure time. So basic example of that is sundial. So sundial is the best example. Before electronics, before mechanical gears, sundial was the only reliable way to tell time. Then there were sign clocks and all, but that was relative time. So absolute time based on the sun, shadows were the best way to tell you the time. So the whole of astronomy started with that. Then there is nighttime astronomy, obviously, that also tells us time and directions and all. But these two aspects, I think, are very important. Are not covered that much in practically not covered that much in our syllabus nowadays.
So there is a nice example used by Varuni. तो जो आपने कहा कि जो हम एक्सपीरियंस भी करते हैं कि अगर हम किसी अपने घर में भी देखें तो जिस तरीके से मान लीजिए कोई लाइट जैसे घर के जो ऊपर के छेद होते हैं उससे आती है और वो ट्रैवल करती है, तो उससे भी कई सारे अनुभव हमारे जुड़े हुए होते हैं. तो आपने एक अच्छा एक एग्जाम्पल वरुणी यहाँ पर लाया है ना. आलोक, आप ये कह रहे थे कि मतलब जो डे टाइम एस्ट्रोनॉमी और जो नाइट एस्ट्रोनॉमी है, नाइट टाइम एस्ट्रोनॉमी, आपने ये शब्दों का इस्तेमाल किया है ना. थोड़ा आप बता सकेंगे कि ये डे टाइम एस्ट्रोनॉमी इसमें क्या होता है और नाइट टाइम एस्ट्रोनॉमी का क्या मतलब है और कैसे ये एक दूसरे से अलग है?
सो देखिए, आप जब रात को चांद को, तारों को और बाकी ग्रहों को देखते हैं तो आप सीधे सीधे अपनी आंखों से देख सकते हैं. आप दूरबीनें आ गई हैं और इलेक्ट्रॉनिक इक्विपमेंट्स आ गए तो उसके और सीधे पॉइंट करके आप देख सकते हैं. तो सबसे पहले मैं एक वार्निंग देना चाहूंगा, किसी भी हालत में सूरज को अपनी आंखों से या टेलीस्कोप या बायनोकुलर किसी भी इंस्ट्रूमेंट से विदाउट प्रॉपर प्रोटेक्शन ना देखे। उसके लिए स्पेशल फिल्टर्स आते हैं, जैसे आपने एक्लिप्स में देखा होगा कि चश्मे जो होते हैं स्पेशल बने होते हैं जिसमें फिल्टर लगा होता है, उसी का इस्तेमाल करके कभी भी सन को डायरेक्टली ऑब्जर्व करना चाहिए। टेलीस्कोप आप अगर लगाएंगे तो आपने देखा होगा मैग्नीफाइंग ग्लास से आप आपने अगर खेला होगा तो एक कागज और किसी भी चीज को वो जला सकता है अगर आप लाइट फोकस करें। तो टेलीस्कोप्स और ये सारे जो है लाइट को फोकस करते हैं तो वो काफी डेंजरस चीज है। तो ये आंखों तक को डैमेज करता है। आप बिना टेलीस्कोप के भी सूरज को थोड़ी देर देखेंगे तो आंखों में आपके कोन्स और रॉड्स होते हैं जो कि एक्सट्रीम लाइट से डैमेज हो सकते हैं। तो अगर हम सन को देख ही नहीं सकते तो सन को स्टडी कैसे करेंगे? तो एक तो हो गया सन के मोशन को ट्रैक करने का। तो उसका बहुत ही सिंपल सा तरीका है, आप डायरेक्टली सन को ना देखते हुए किसी भी एक फिक्स्ड ऑब्जेक्ट को देखेंगे तो उसकी शैडो को ट्रैक कीजिए। जहां शैडो होगी उसकी ऑपोजिट डायरेक्शन में सन होगा। अगर शैडो इधर से इधर जा रही है तो आप समझ जाएंगे कि सन कहां से कहां जा रहा है, और शैडो की लंबाई आपको थोड़े से गणित को लगा के सूरज की ऊंचाई बता देगी। तो दोनों रात को एस्ट्रोनॉमी करने में, दिन को एस्ट्रोनॉमी करने में बेसिक आइडिया आपका यही है कि चांद तारे कहां से कहां मूव कर रहे हैं। अगर आपको एक्लिप्स प्रिडिक्ट करने हैं, आपको उनका मोशन प्रिडिक्ट करना है, तो रात को तो आप सीधे सीधे देख सकते हो। दिन में देखने का जो एक ही तरीका है वो है किसी भी चीज की शैडो देखी, क्योंकि डायरेक्टली देखना सेफ नहीं।
तो जैसे आपने ये कहा कि दिन में हम लोग जो है वो सन जिन ऑब्जेक्ट्स की शैडो कास्ट करता है उसको ट्रैक करते हुए हम लोग कुछ चीजें देख सकते हैं, समझ सकते हैं, जिसमें कि सन की जो मोशन है उसको समझा जा सकता है। क्या डे टाइम एस्ट्रोनॉमी में सूरज के अलावा और भी किसी ऑब्जेक्ट को कंसिडर किया जाता है डे टाइम एस्ट्रोनॉमी में? थोड़ा बता देंगे?
देखिए, दिन में सन के अलावा सिर्फ एक या ज्यादा से ज्यादा दो चीजें दिखाई दे सकती है। दिन में आप चांद को यानी मून को भी देख सकते हैं। एक बड़ा इंटरेस्टिंग चैलेंज है वीनस, जो कि मून और सन के बाद सबसे ब्राइट ऑब्जेक्ट है स्काई में, वो भी दिन में देखा जा सकता है, बट इट्स मोर ऑफ अ चैलेंज। उसको आप दिन में देख के कुछ प्रैक्टिकल ऑब्जर्वेशन नहीं देख सकते, मतलब कुछ प्रिडिक्ट नहीं कर सकते। बेटर है आप वेट करो, या तो उसको मॉर्निंग में सन राइज से पहले या सनसेट के बाद देखना। वीनस को हटा दे तो मून को देख के भी बहुत बड़ी इंटरेस्टिंग चीजें जो कर सकते हैं, जो डे टाइम में और नाइट टाइम में दोनों हो सकती है। मून का जो फेज होता है यानी चंद्रमा की जो कलाएं होती है, आपने शुक्ल पक्ष, कृष्ण पक्ष यानी वैक्सिंग फेज, वेनिंग फेज ये देखा होगा, अमावस्या, पूर्णिमा, ये सारा साइकिल जो है हम सब टेक्स्ट बुक में पढ़ते जरूर है, लेकिन अगर आपने तिथि और इन सब के बारे में सुना होगा तो आप शेप ऑफ मून, जो मून का जो फेज है, उसको देख के ये बता सकते हो कि उसके रिलेटिव में सन की पोजीशन कहाँ है और उसका राइज और सेट टाइमिंग कैसे होगा। लेट मी गिव एन एग्जांपल। जब पूर्णिमा होती है तो सन जो है, आपने ऑर्बिट में देखा होगा कि अर्थ है, सन है और मून है। जब पूर्णिमा होगी, सनसेट के ठीक ऑपोजिट डायरेक्शन में मून राइज हो रहा होगा। अमावस्या होगी तो स्काई में जो मून है वो एकदम पास होगा। तो जितना बड़ा फेज ऑफ द मून है, स्काई में मून का एंगुलर सेपरेशन सन से उतना ही होगा। ये प्रिसाइज, इतना प्रिसाइज है कि जो तिथियां कैलकुलेट करते हैं, प्रथम, द्वितीय, तृतीय, ये सब है, इट्स बेसिकली डिवीजन ऑफ दिस 360 डिग्री into equal parts. So using that you can calculate the rising and setting time also. But this is true for daytime and nighttime astronomy also. So now we don't bother about all these things. But चंद्रमा के बारे में इतने गाने और अपने कल्चर में इतने रेफरेंसेस दिए हैं, आधा है चंद्रमा, 14वीं का चांद, और because it was a means of keeping the time. So that is also one important aspect of observing both daytime and nighttime.
तो ये आपने काफी अच्छी जानकारी दी आलोक। हम लोग दिन में सूरज के साथ साथ कभी कभी चंद्रमा भी देख लेते हैं। कभी मतलब सूरज के बाद होता है, कभी सूरज के पहले होता है, लेकिन दिख जाता है। पिछले कुछ दिनों में मैंने भी चंद्रमा को देखा था। आई थिंक नवंबर में एक सूर्य ग्रहण हुआ, तो सूर्य ग्रहण के पहले पहले दिन में चांद दिखाई दे रहा था, और फिर 26 नवंबर को जो सूर्य ग्रहण हुआ उसमें उसके सामने से गुजरता हुआ देखा। तो ये दिन में भी दिखाई देता है चांद। तो चलिए आप हम आगे बढ़ते हैं। आपके जो लेख है थोड़ा उसकी तरफ बढ़ते हैं। कैन यू टेल अस अबाउट how do we use the study of shadows to connect the experiments which you described uh, in your article? This how we can say, relate this concept in classrooms?
Maybe I'll start with a few
Yeah,
connections and
Varun.
then Alok can take over.
Yeah.
So there are a lot of connections and in fact interdisciplinary connections, as I keep telling teachers about this. So see, there's of course geography and in terms of where you are, what is your latitude, what is your longitude, and how that affects your shadows. There is of course physics in Kepler's laws and how you go around, how the earth goes around the sun. There is a lot of mathematics as well, because you're calculating angles and ratios and thinking about similar triangles. So there are a lot of different connections to different parts of what students learn, maybe at the middle school level, but Alok can also tell you about many much more complicated things that are only that can be accessed even at a college level. So there are a lot of things that you can do with this, a lot of geometry, a lot of mathematics also. But one of the things that I might say this a couple of times during this session, because I think that this is a very important part of these shadows experiments, is that I think that this is one of the few ways that students can actually directly experience I mean, directly kind of look at how the revolution and rotation of the earth, right? So this is something that is taught maybe in geography, in physics, in like all these different subjects, but you're just told that there is nothing, there is no evidence that is being pointed to when you learn that. You're just told, okay, like this, earth goes around the sun, like that's great. But this is one of the things that students can actually measure on a regular basis, on a daily basis, and do quite scientific measurements. And it gives them an idea of where the sun is relative to the earth, and where the earth is in its orbit around the sun, as well as during the day where you are. So this, I think, is a very deep sort of concept that can come out of not just these two activities, but as we'll tell you a bit later, maybe there are a lot of different activities you can do that are just centered around shadows. So this is something that I think is sort of maybe beyond the textbook, but like somewhere in there as well. So Alok maybe can add a few things.
Yeah, I see a question in the comments. I think, is it possible to do daytime astronomy by suitably covering the telescope with filters or connecting the telescope to a protector? So I don't know what you mean by protector, but there are specialized filters available to view the sun. So you can use that, and care has to be taken while using that, because even if there is one scratch on the surface, the scratch is enough to let in a lot of light. So there are proper ways to handle that. So you have to hold the filter from the side, don't hold it with sharp objects, or don't hold it from the middle. So all these, there are a few other ways also. You can safely project the sun. So you can use mirrors and project the image of the sun. Then there is a projection box also, where you can use a telescope. You don't look through the eyepiece, you just project that image on a white piece of paper. So 3 or 4 different ways are there. The daytime, normally people are not bothered to view the sun directly. That happens only at the time of solar eclipse. So you can search for safely viewing the solar eclipse, how to safely view that. So you will find a few of these methods, including the filters and projection that I'm talking about, in ways that you can use on any other day as well.
ये आपने सही बात कही आलोक, क्योंकि जैसे आपने पहले भी बताया कि किस तरीके से सन को सीधे सीधे देखना एक घातक हो सकता है। जैसे कि लेंस से अगर हम किसी कागज को जलाएं, जो हम लोग बचपन में खेल खेलते भी थे, तो किसी कागज को या किसी माचिस की तीली को जलाने का, और उसकी जो किरणें होती है जो फोकस हो जाती है, तो वो बहुत ही घातक होती है। और टेलीस्कोप में तो कई सारी लेंस होती है, तो उसे देखना बहुत ज़्यादा धोखादायक हो सकता है। तो ये हमेशा से ही हमें अल्टरनेट जो मेथड्स है सूरज की तरफ देखने की, वो उनकी तरफ उनको उनका इस्तेमाल करना पड़ेगा। जैसे कि आपने बताया कि फिल्टर इस्तेमाल करें। इन फिल्टर्स में क्या होता है, आप थोड़ा बता पाएंगे कि किस तरीके के फिल्टर्स होते हैं जो कि
हाँ
सेफ होते
देखिए।
हैं, और कहाँ कहाँ
जी,
से हम लोग इसको मिल सकते हैं हमें?
देखिए आप अगर टेलीस्कोप पे लगा रहे हैं तो टेलीस्कोप विंडोज के पास ही उस टेलीस्कोप के साइज के फिल्टर्स आते हैं। बेसिकली फिल्टर का काम होता है लाइट की इंटेंसिटी को कम करना, और कुछ स्पेशलाइज फिल्टर्स होते हैं जो डिफरेंट वेवलेंथ्स को भी ब्लॉक कर देते हैं इंटेंसिटी कम करने के साथ साथ। तो अलग अलग कलर्स में भी सन दिखाई देता है। एक हम लोग अमेचर्स हमारे ग्रुप में एक होता है वेल्डर्स ग्लास। आपने देखा होगा कोई जो वेल्डर्स होते हैं वेल्डिंग करते हैं तो सामने एक शील्ड रखते हैं ताकि चिंगारी से भी बचे, लेकिन उसके अंदर एक ग्लास लगा होता है। वो इसलिए क्योंकि ब्राइट वेल्डिंग को देखने से उसमें भी आइज डैमेज हो सकती है। तो वो वेल्डर्स जो ग्लास होता है वो भी हम लोग ने छोटे छोटे पीसेस लाके रखे और उससे भी सन को और एक्लिप्स को देख सकते हैं। दैट इज ऑल्सो वन वे। उसमें अगर आप वेल्डर्स ग्लास को देखेंगे तो ग्रीनिश टिंज दिखाई देगी बिकॉज इट रिमूव्स द अदर कलर्स ऑफ द लाइट। सो इसी तरह एमेचर्स कई एक्लिप्स देखने के जैसे अलग अलग कॉन्ट्रैप्शंस हैं, प्रोजेक्शंस के अलग अलग बॉक्सेस हैं, बहुत कुछ ऐसी चीजें हैं जो लोगों ने बनाई हैं। तो फिल्टर तो आपको परचेस करना पड़ेगा। इवन विदाउट परचेसिंग विद टेलीस्कोप या यू हैव टू यूज अ फिल्टर फॉर द टेलीस्कोप, बट बिना टेलीस्कोप के आप अगर देखना चाहते हैं तो कुछ अलग अलग तरीके हैं दैट if we want we can cover those in a later session, so that there are many other methods to view the sun safely.
हम्म, ठीक 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 आलोक। तो हम लोग फिर से हमारे एक जो लेख है उसकी तरफ बढ़ते हैं। व्हेन इज नून। इसमें आपने कहा था कि भाई जो मध्याह्न होती है, जो दोपहर होती है, ये 12 बजे नहीं होती है। जैसे कि हम सभी का मानना होता है कि भाई 12 बज गए तो दोपहर हो गई। ऐसा मतलब ऐसा क्यों होता है, आप थोड़ा बता पाएंगे कि मतलब ये पढ़कर थोड़ा सा एक लगता है अजीब कि सर पे सूरज आ गया तो ऐसा लगता है दोपहर हो गई, लेकिन आपने कहा है कि ऐसा हमेशा नहीं होता।
हाँ, देखिए नून इज अ वेरी टेक्निकल टर्म। नून का मतलब होता है जब सन जो है नॉर्थ साउथ लाइन जो होती है उसको कहते हैं हम मेरिडियन। मेरिडियन, लोकल मेरिडियन, क्योंकि हर जगह की मेरिडियन अलग अलग होती है। सो जब सन देखिए सनराइज होता है जब ईस्टर्न होराइजन यानी क्षितिज से जब सूरज ऊपर आता है उसको हम सनराइज कहते हैं। पश्चिम की तरफ जब डूबता है नीचे चला जाता है उसको सनसेट कहते हैं। जो नून होता है इन दोनों का मिड पॉइंट होता है, और वो जब मेरिडियन क्रॉस करता है उसको हम नून कहते हैं। अब बात आती है कि 12 बजे क्यों नहीं होता। देखिए अभी मेरी घड़ी में, आपकी घड़ी में, पूरे इंडिया भर से हम लोग यहाँ पे जुड़े हैं, सबकी घड़ी में अगर घड़ी करेक्ट चल रही है तो टाइम एक ही बताएगा। तो ये स्टैंडर्डाइज हमने अभी कुछ रिसेंटली ही किया है। बहुत पहले ऐसा कोई स्टैंडर्डाइजेशन टाइम का था नहीं। तो आप अगर गुजरात में देखें और आप अगर गुवाहाटी में देखें तो दोनों में जो टाइम है, लोकल टाइम है, वो अलग होगा। लोकल टाइम इज समथिंग जो हम पढ़ते नहीं, क्योंकि हमने टाइम स्टैंडर्डाइज कर दिया। गुवाहाटी में सुबह 4 बजे सूरज उग जाता है और गुजरात में वही उगने में 2 घंटे सुबह के 6-7 बज जाते हैं। तो वो डिफरेंस इसलिए क्योंकि दोनों अलग अलग लॉन्गिट्यूड में है। पृथ्वी गोल घूम रही है, लेकिन जो भी दो जगह हम अलग अलग लॉन्गिट्यूड की लेंगे उन दोनों का टाइम डिफरेंस होगा ही। इट्स अ मैन मेड कॉन्स्ट्रक्ट। टाइम जोन जो है हमने बनाए इसलिए ताकि ये ना हो कि हम अगर अहमदाबाद और गुवाहाटी के बीच में कोई दो कोलैबोरेट कर रहे हो तो दोनों में अलग अलग घड़ी हो। यहाँ तक कि अगर आप 10 किलोमीटर का डिफरेंस भी ट्रेवल करें तो दोनों के टाइम में डिफरेंस होगा। ऑल्दो इट विल बी स्मॉल, यू कैन कैलकुलेट इट हाउ मच डिस्टेंस कॉरेस्पॉन्ड्स टू हाउ मच टाइम डिफरेंस, बट द रीजन फॉर स्टैंडर्डाइजेशन इज द कॉज ऑफ दिस। बिकॉज अब हमने बोल दिया कि गुवाहाटी में भी सेम टाइम है और ये अपने गुजरात में भी सेम टाइम है, then all of us are forced to have the same time, and that is one of the reasons why the time is different. That's why the 12 p.m. is not the same. 12 p.m. is supposed to be the noon time, but it won't be the same because we are artificially following the same standardized clock.
Okay, so you mentioned about standardized time. So in India, how we standardize this time for Gujarat also and for Assam also?
Okay, Indian Standard Time, it's 5.5 hours running before the GMT. So Greenwich geography में आपने latitude longitudes पढ़े होंगे, तो जो लंदन यानी यूके के थ्रू एक स्टैंडर्ड हमने longitude की लाइन को मान लिया है, that is supposed to be the time zone 0. So उसी के आगे ईस्ट और वेस्ट में we have defined different time zones. Now India standardized the whole of time zone. There were historical and पॉलिटिकल रीजंस ऑल्सो कि एक यूनिटी बनी रहे इंडिया में. देयर हैव बीन कमिटीज दैट सजेस्टेड कि इट्स वेरी लॉन्ग. इफ यू सी अदर टाइम जोन्स इन ज्योग्राफी, काफी पतले स्ट्रिप्स में होते हैं. इंडिया का एक्सपेंस बहुत ज्यादा है, बट वी वांटेड टू हैव अ सिंगल टाइम फॉर ऑल ऑफ इंडिया. दैट्स व्हाई a standard time zone was defined. And it's interesting why it's from Allahabad also. आप कहीं पे भी बीच में स्टैंडर्ड जोन नहीं कर सकते. The way it is decided is that जैसे हमने GMT को स्टैंडर्डाइज कर दिया, now there are 360 degrees of longitudes, and now that has to be that is equally proportional to 24 hours. एक घंटे में 15 डिग्री का डिफरेंस आता है. So अगर अभी लंदन में सुबह के 10 बज रहे हैं और you define a time zone ki we are 4 hours 37 minutes off, so it will be very chaotic. Time zones, so the standard set in the world is the time zone has to be a multiple of half an hour. So you can be half an hour, 1.5, 2.5, 2, 3, multiple of half an hour offset from the Greenwich Mean Time. इसका मतलब क्या, जैसे मैंने कहा 360 degree divided by 24 is 15 degrees per hour. So for half an hour that would be 7.5 degree. So you can only have a standard meridian in a multiple of 7.5 degrees of longitude. And the middle of India, if you take middle longitude of India, that is near Uttar Pradesh. And so Allahabad was one of the cities. Allahabad is not exactly 82.5, but yeah, the standard meridian of India is defined as 82.5 longitude because it is a multiple of 7.5. 7.5 into 10 is 75. Add 7.5, so 11 time, you'll get 82.5. And that is somewhere in between India, and that now we define as the time for all of India taken together.
तो जैसे मतलब वरुणी और आपकी बातचीत में पहले भी आया कि हमारी जो जो शैडो है वो हमको बता सकती है कि भाई कब नून है ना. लेख में भी आपके वो एक बात आई है. लेकिन जैसे अगर हम इसको करके देखें कि आपने कहा कि एक इंडस स्टैंडर्ड टाइम है और एक लोकल टाइम है, सो हाउ वी कैन मेजर दिस डिफरेंस and which age group we can address with these activities? Means I'm talking about especially for the school students. If I wanted to do this kind of activity with school students and wanted to measure difference between Indian Standard Time and my local time, तो कैसे करें इसको? वरुणी, आप कुछ बता सकते हैं इसमें?
Yeah, so this, so like Alok said, we have some standard, time zone that we all live in. If you go to different countries, they are maybe 1 hour different, 2 hour different, so something like that. And you might know this because you might have family living in Dubai, or you know that there's a time difference. But I think it's nice for students to see that. That how this is, it's not really just arbitrary. It's not just that India decided that we want to be in this time zone, and therefore we want to have this time, so everyone has to have this time. So in some sense there is a reason for picking this time zone, but also to note that there are differences from that. So 12 p.m. IST is a time where we all agree and we call it noon, but it's not really local noon. So it's not when the sun is highest for you, right? So whatever location you are at, the sun rises at some time, the sun sets at some time, and in between those two times, like Alok was saying, it is going to be the highest in the sky, right? And what we are calling local noon is that point when the sun is highest in the sky. So I'm sure, this is something that we all know from experience, which is that in the morning, your shadow is very long. and then it gets shorter and shorter and shorter, and then after noon it gets longer and longer and longer, right? So this noon is a very special time. It's if there are sort of maths teachers around, it's your minimum, right? It's your minimum shadow in the whole day. So this is and there are it not only tells you, so doing this sort of experiment or activity where you find your local noon, you do a couple of things. One, you find out for you when the sun is the highest. You can also tell just from this measurement, whether you are east or west of the central line, right? Like the standard meridian of India. There are a couple of different ways that, you can do this pretty much with, I think the youngest age group that I have done something similar with is maybe 6th standard, 7th standard. But as you go to higher standards, they may want to calculate more things like how, what is the rate of change of the angle. The possibilities, there are a lot of different possibilities here. But yeah, the youngest age group I think you could do it with was even 6th standard, because all you need to do is measure your shadow, measure it regularly, write it down, and see when it's minimum. And that's it. There are a few other ways also that you can find local noon, which maybe I'll talk about later. But this is one of the easiest ways, right? The other thing that we have done, this I think we have done with teachers, is you can also, and especially if there's school systems, right? Or if you can pair two different schools or two different teachers from different parts of the country, and they can do the same measurement at the same time IST, right? So if you pick someone from, someone say who's working near Amol, which is in Rajasthan, and maybe someone in Bhubaneswar, and you ask them to do the same measurements at the same time, and sharing the measurements is quite easy, and it's quite nice. It might be quite nice for students to see that difference, that we're measuring it at the same time, but our minima are different. And actually, the shadow lengths will also be different. And that's a whole different story to do with location that maybe we will come to a little later.
Yeah, just to add one more thing. So, if you know AM and PM, we have time before noon. We call it AM and PM. So it's called anti-meridian and post-meridian, ANTE meridian. So I told you north-south line when the sun crosses, and as Varuni mentioned that it is at its highest. So before, when the sun is before that meridian line, from sunrise to that, we call it before. Anti means before, I think in Latin. So before meridian, and once it starts to go down after the noon, then it's called post meridian. So the terminology that we have been using in time is also based on that only, AM and PM.
ओके ये मतलब ये जो एएम और पीएम को लेके जो एक डाउट होता है ना, ये इसका किसके एब्रिवेशन है ये आपने एक अच्छी बात बताई कि इसके ये इस वर्ड्स का एब्रिवेशन है ना। जैसे वरुणी आपने ये कहा ना कि भाई 6th क्लास के स्टूडेंट्स के साथ इसको किया जा सकता है ना, लेकिन इसमें कई सारी बारीक चीजें भी, जैसे आपने कहा कि मेजरिंग ए शैडो। सो किस तरीके से इस शैडो को मेजर किया जाता है? कैन यू टेल अस मोर अबाउट this method, how one can measure shadow, minimum shadow?
So what we suggest in this snippet is that you just take a measuring tape, and you just need to have a friend with you, and every 10 minutes you just use the measuring tape, which you can get, you can borrow it from your local tailor, or you can get these tapes quite easily, or even a meter scale from your school. So you can just measure your shadow every 10 minutes, and there's a suggested time frame. Depending on where in the country you are, we have a suggested time frame, and you measure it for an hour, and in that hour or so, you should see your shadow decreasing and then increasing again. And the point where it kind of is the minimum is what we will end up calling local noon. There's another way to do it, which actually today I did with some teachers, and maybe Maybe I'll just share my screen if that's okay. I'll show a few photos. Um, so this is just wait for it to kind of sync.
हाँ अभी
Yeah.
ये प्रेजेंटेशन आपका लाइव हो रहा है या
Yeah.
दिख रहा है वरुण जी?
So these are a couple of different things that we've done. These are the things with students. Again, like I was saying, we can do it anywhere. So this was just on the beach in Chennai. This is in a ground in a school. And we've also done these sessions online. And we've plotted some of this data. So there are various ways of doing this. But I was hoping to show you this image, if I can zoom in a bit. But what you can do, so you can see this image. So this is actually something that we did just today. I don't know if you can see it very clearly, but there are concentric circles here. So we've put a piece of chalk in the middle and there are concentric circles around it. One of the other ways of finding local noon is you follow the shadow of this piece of chalk and you mark when it crosses any of these circles and wait for it to cross that circle again. And the time that is exactly between those two times, between the first time it crosses the circle and the second time it crosses the circle, is also local noon. So that's another way that you can do it. There is also I think there are a few other ways as well, including what we suggest is to also look at sunrise and sunset times. You can find this in your newspaper, usually a sunrise and sunset time. And the time that's exactly between sunrise and sunset, or almost exactly, I think maybe Alok can continue. That's almost exactly the time in between is when your local noon is as well. I kind of went to different places. Amol, did I sort of answer your question? I went to a few different places, but yeah.
No, yeah, you answered. अलग अलग तरीके से कैसे मेजर किया जा सकता है, ये काफी ट्रिकी बात होती है कि एक शॉर्टेस्ट शैडो को कैसे मेजर किया जाए, क्योंकि कई बार तो मतलब वो इंच टेप जिसकी आप बात कर रहे हैं टेलर के पास से जो लेनी चाहिए, उससे भी शैडो मेजर करना कई बार मुश्किल हो जाता है। और जैसे आपने कहा ना कि देर आर डिफरेंट टाइम यू हैव मेंशन फॉर डिफरेंट पार्ट, कि आई थिंक आईएसटी के ईस्ट में कब होगा, आईएसटी के वेस्ट में कब होगा, शायद इस तरीके का कुछ डिफरेंस टाइम होगा, जो कि आलोक भी मेंशन कर रहे थे, जो टाइम डिफरेंस है लोकल नून में। तो इसको भी ध्यान में रखना बहुत ज़रूरी है। तो मतलब आपने सही बात कही वो कि भाई अलग अलग तरीके से उसको मेजर किया जा सकता है ना। आलोक, आप कुछ जोड़ना चाह रहे हैं इसमें?
नहीं, आई थिंक प्रैक्टिकल ऑब्जर्वेशंस वरुण ने काफी कवर कर ही लिए हैं। यू कैन यूज डिफरेंट ऑब्जेक्ट्स फॉर शैडोज। आप खुद भी खड़े हो सकते हो, किसी पोल का यूज कर सकते हो। जो छोटी चौक दिखाई थी, जस्ट जितना बड़ा ऑब्जेक्ट होगा शैडो की स्केल उस हिसाब से चेंज हो जाएगी। यू डोंट नीड अ मेजरिंग टेप फॉर स्मॉल पेन और चौक, वो स्केल से भी हो सकता है जो 15 सेंटीमीटर्स का होता है स्टूडेंट्स के पास।
अच्छा आलोक और वरुणी, जैसे कि मैंने सुना है कि भाई जीरो शैडो जब होती है तो मतलब आपके पैर के नीचे आपकी शैडो होगी, है ना, मतलब आपको दिखाई नहीं देगी। लेकिन हिंदुस्तान के जो कुछ ऐसे लोकेशन है जहाँ से ये जीरो शैडो में जीरो शैडो होती नहीं है, इसके पीछे के क्या रीजन है, मतलब थोड़ा इसके बारे में बता पाएंगे?
So this zero shadow day is this phenomena which happens twice a year and only in the tropics. So ये काफी special है because Tropic of Cancer goes through about where Bhuj is. So almost half of the country. So if you're south of the Tropic of Cancer, so between the Tropic of Cancer and the equator and the Tropic of Capricorn, in these places there are exactly 2 days of the year where your shadow will be zero. So there are maybe Alok, you want to maybe show us when and how this happens?
I'll go through the visualizations in the next questions, then it will be clearer. So, because of the northward and southward motion of the sun, what we know as Uttarayan and Dakshinayan, so that's why there are 2 days. मतलब एक बार सूरज ऊपर ऊपर जा रहा है, मतलब आसमान में भी ऊपर जा रहा है, और जब दक्षिणायन होता है तो its height is going southward. So for these 2 times it would cross your overhead point. That's called zenith. So I'll try to show this in a visualizations after some time.
हाँ, ये काफी इंटरेस्टिंग है क्योंकि मैं ये सवाल जो है काफी बार दिमाग में आता है कि कई जगह पे लोग जो है वो अपने पैर के नीचे शैडो देखते हैं लेकिन कई लोकेशन से नहीं देख पाते। तो उसको लेके आगे हम लोग चर्चा करेंगे। जैसे हम लोग
can I just sorry Amol, I'll just add one thing. एक thing मैं add कर देती हूँ. So one of the things that we have seen when we do this with students, a lot of people immediately assume that every day they at noon their shadow is zero. This is something that is a common idea because you think the sun is very high, it's right overhead. So this is something that is nice for students to see also, that that's not exactly true. So not every day at noon is your shadow zero. There are only special days in special places where it is. So this is one of the other kind of advantages of these sort of activities, which is that there may be things that you kind of assume because I think we'll go over this a bit later also, that आपके textbook में लिखा है the sun rises in the east and sets in the west. Now that is another thing that everyone learns and they say like लिखा है हो गया. And it's the same thing with noon, right? Like, so people think, okay, noon I have the sun is directly overhead. So experiments like these which are very easy to carry out. So we'll talk about the experiments to do with sunrise, sunset, and where sun rises and where sun sets. But also this idea that at noon the sun is directly overhead, which is not true. And this is something that students can actually see themselves and try and measure when it is actually at overhead and how it moves. So sorry, I just wanted to add this to this zero shadow thing.
हाँ, नहीं, आपने ये काफी अच्छा एक पॉइंट लाया कि usually people thinks that every day their shadow become zero, but this is not true for any day, means only for few special days, and not for every location. If you are north of this Tropic of Cancer, then your shadow will not go exactly under your feet. So this is quite interesting fact, and I think this can also open up discussions with the student. When teacher can open up discussion with the student, what their location is on the Indian geography and how this place is matter. So that's one can be discussed with the student also. Varuni and Alok, you mentioned about the estimating local noon time, and you also mentioned that you can estimate this by knowing from different method and from newspaper also, from almanac also. But can student and teacher can estimate this sunrise time or sunset time at a particular location? How this is related to the estimating local noon time also?
So estimating local noon directly is pretty straightforward because you have to find the time where the shadow is minimum. Calculating sunrise and sunset times by yourself is a very difficult task. So because there are many things involved. First of all, it depends on your latitude, and every day the path of the sun keeps on changing. So what एज आई वाज मेंशनिंग उत्तरायण एंड दक्षिणायन, जब सूरज ऊपर और नीचे बढ़ता है आसमान में तो उसका राइजिंग पॉइंट भी चेंज होता है. आई विल शो दिस इन द विजुअलाइजेशन एज वेल, एंड आई थिंक in our next article also it is mentioned that the rising and setting point of the sun is not exactly east and west all the time. So because of that, and also there is one more factor which is called equation of time. So if you let me cover this point. I think in the snippet we have mentioned that on this particular day the local noon time is at this time. So on different days for the same location, the local noon time is changing. If it was only because of the longitude, as we have already discussed, then it would have been the same throughout the year. But there is one more complication. Because the Earth's orbit around the sun is not perfectly circular. It's slightly elliptical. So because of Kepler's law, the second law, the rate at which the Earth is going around the sun keeps on changing. So sometimes it's fast, sometimes it's slow. So Earth and we don't know the speed difference directly, but what we see is the speed difference in the sun. So when Earth is moving faster, the sun will the sun will move faster in the sky, and when Earth is slow, we will see the sun as moving slow in the sky. So exactly at the same time, if we look at the sun day after day, it won't be coming at the same location. Not only south and north and south direction, east and west, because the clocks will run faster or slower. That's why it's called equation of time. I think in medieval times the equation was used to correct the time the watches were showing, the sundials were showing. So this is a slightly advanced concept. So that's why calculating the rise and set timings on yourself is a bit tedious. An advanced teacher or advanced student who knows a lot of mathematics and all these calculations can do it. But the noon part is simple because, as Varuni mentioned, once you know the rise and set timings, it's just a matter of finding the midpoints. And anyways, that time is published for all the location.
तो आगे बढ़ने से पहले मैं हमारे जो दर्शक हैं, हमारे जो पाठक हैं, जो ये लाइव वेबिनार देख रहे हैं, उनसे ये मैं दरखास्त करता हूँ कि आप अपने सवाल भी पूछते रहे. आपके सवाल अगर आप पूछेंगे तो उन्हें भी हम लोग यहाँ पे डिस्कस कर सकते हैं. तो आप आपके सवाल पूछते रहिए. तो हम लोग आगे और इस चर्चा को बढ़ाते हैं. जैसे कि आपने कहा कि एक शुरुआत में इस वेबिनार के कि हिस्टोरिकली अगर हम देखेंगे तो ये जो सन का जो मोशन है, ये इसने हमें टाइम कैलकुलेट करने में मदद करी. तो थोड़ा आप हमें बताएंगे क्या कि किस तरीके से ये टाइम कैलकुलेशन जो लोगों ने शुरू किया शुरुआत में, किस तरीके के इक्विपमेंट्स को यूज किया, किस तरीके के, मतलब आपने कहा कि भाई एक सिंपल स्टिक से किया था, लेकिन और भी किस तरीके के इंस्ट्रूमेंट लोगों ने इजाद किए, थोड़ा सा उसके बारे में भी आप कुछ बता पाए तो बढ़िया रहेगा.
देखिए, टाइम कीपिंग की हम बात करें, इसमें नापने के लिए जो इंस्ट्रूमेंट्स की हम बात कर रहे हैं, तो इसमें दो टाइप के यंत्र होते हैं. एक होता है एक दिन का समय. इफ यू वांट टू नो द टाइम ऑफ द डे, कितना बजा है, फॉर दैट वी आर डिपेंडेंट ऑन शैडो, द शैडो मूविंग थ्रू आउट द डे. तो वो उसका आंसर है सनडायल. सो जंतर मंतर, अगर आपने नाम सुना होगा, जयपुर में सबसे बड़े जंतर मंतर केंद्र सम्राट यंत्र जो जंतर मंतर का, इट हैज एन एक्यूरेसी ऑफ 2 seconds. इतने बड़े स्केल पे मार्बल से बनाया गया स्ट्रक्चर है, एंड द शैडो जो उसमें सीढ़ी बनी है, उसकी शैडो उस पे मूव करती है. सो जस्ट यूजिंग शैडोज इट इज टेलिंग यू द टाइम टू एन एक्यूरेसी ऑफ 2 seconds. दैट इज बिकॉज उसको इस इंक्लाइन पे बनाया गया है कि जिस एक्सिस पे जो सन मूव कर रहा है, फॉर ऑल द डेज ऑफ द ईयर इट विल कास्ट द शैडो ऑन द सेम प्लेट. तो उसको इस इंक्लाइन पे बनाया. दैट इंक्लाइन इज एक्चुअली इक्वल टू द लैटिट्यूड ऑफ द प्लेस. ऐसा बनाने से you can get the time using shadows. This is the most advanced example of sundial. So rudimentary sundial का आइडिया भी यही होता है कि बहुत पहले भी इंसान शैडो से देख ही सकता था कि पूरब की तरफ सूरज आया मतलब सुबह हो गई. ये तो अंडरस्टूड है. एंड इफ यू जस्ट सी द शैडो, आपको भी आइडिया होगा कि जैसे जैसे वो शैडो छोटी होती जा रही है, द time is changing. So all that aside, ये हो गया sundial. Let me cover one more. I think few questions have been asked regarding this also, about Konark Temple and other. So I don't know specifically about Konark Temple, but archaeoastrology. मतलब if you see a lot of structures made by ancient man, they were like positioned to मॉनिटर द पोजिशन ऑफ द सन, जो मैंने अभी तक आपको बताया एक दिन में परछाई के मोशन को ट्रैक करने के लिए बनाया। स्टोनहेंज इज द बेस्ट एग्जांपल। बेसिकली क्या होता है, जब ये उत्तरायण दक्षिणायन की बात में कर रहा था, तो राइजिंग पॉइंट एंड सेटिंग पॉइंट ऑफ द सन इज ऑल्सो शिफ्टिंग फ्रॉम नॉर्थ टू साउथ, रहेगा ईस्ट की तरफ, it will go slightly towards north of east, and जब सर्दियां आती है तो south of east जाता है. I'll demonstrate this using your visualization. And setting point is also shifting that. So that was the way to track season. जो geography में हम पढ़ते हैं season, summer और winter solstice जो पढ़ा है, equinox पढ़ा है, so that has a direct bearing on the seasons that we observe, because the day length and night length keep on changing because of this motion of the sun, and it affects the energy we are receiving on Earth, and correspondingly the season keeps on changing. So जो geography में tropical हमने ये सब पढ़ा है, tropical lines हुई और जो solstice और equinox हुए, all to keep track of all that, जो temples हुए या पुराने structures हुए, all different civilizations have positionings of stones and structures such that they can track the rising and setting point of the sun, which I think is neglected a lot nowadays, because आजकल हमारे पास समय नहीं कि हम सूर्योदय या सूर्यास्त को देखें, but it tells you a lot. I think I'll cover this in when we go to our next topic.
So
I'll just add. So you don't have. So I'll just add that. So there are sites like this. These are megalithic sites. So they are very, very old sites, and there are sites even in Jharkhand. In various parts of the country, a few famous ones are in Jharkhand, where there are stones that they have found that people have put in a particular position, such that on the equinox, the sun rises exactly between, or I think the sun sets exactly between those. So there are sites like this, not just, not just that go even much before, like Alok was saying, just the sundials and things that we make. So if you're in Jharkhand, you should find these sites. I think I would love to go at some point. So if you find them, send us pictures.
Yeah. There are sites mentioned by Alok also. In Jaipur, there is a Jantar Mantar. I think in Ujjain, Varanasi and Delhi, they also have such kind of instruments. But these are, I think, quite new. Means built, I think, 300 to 400 years back. But the sites you are mentioning, they are, I think, much back in history. So, वरुणी, थोड़ा इससे आगे बढ़ते, जैसे इक्विनॉक्स और इनकी बात हो रही है, समर सोल्स्टाइस, विंटर सोल्स्टाइस की, जो आपके लेख है उसमें भी आपने जैसे इक्विनॉक्स को लेके एक एक्टिविटी बताई है, थोड़ा सा उसके बारे में जानकारी आप देंगे, किस तरीके से इसको किया जाए, कौन सी कंसेप्ट जो है इसके साथ हम लोग डिस्कस कर सकते हैं?
So the equinox article is also it's related to similar things. So I think what we've been talking about now is what happens over the course of a day. So how does the sun move in the sky over any given day? Now, so something that students might have again experienced in some way, right? Like if they're in a classroom for the whole year. There are certain desks that will get sunlight, in the summer months only, and certain will get in the winter. So this is something that everyone might have somehow observed. But to see that the sun moving through the sky also changes over the course of the year. So the sun doesn't take the same path every single day. So that's another that's another movement of the sun that we can see through these shadows. So the equinox article, is supposed to is a activity that can be done on the equinox. So there are a couple of different things that you can calculate on that day. So noon, of course, like we said, you can calculate on any day, right? Any day you can calculate local noon. You don't have to do it on a particular day. But on the equinox is a bit special. So you can, of course, calculate noon. because you can do that on any day, you can do it on the equinox. But what you can also calculate very simply is you can also calculate your latitude. So what we've been also talking about is not only that the time of day matters for your shadow, your location, your time of year matters as well, but finally your location matters as well, right? So what your the latitude at which you are, uh, depending on that, your shadow length and direction will be different, right? So what we do what we suggest you can do on the equinox. So the equinox happens twice a year, and so on 20th March and 23rd September. So at local noon, so you can have done the local noon experiment, figured out when local noon is, and then at local noon on the equinox, you measure your shadow length. Okay, so this is another thing that using that shadow length, now you can calculate the angle of the sun's rays, right? So now that angle, you can do it with trigonometry. I think there was a question on the chat asking about daytime astronomy and trigonometry. So definitely there's trigonometry involved. But again, if you're doing this at a sixth standard level, a sixth standard student might not, want to do tan theta, cos theta. I mean, I don't want to do tan theta, cos theta on most days. So, but all you can do is you can just draw a triangle, right? So you draw your height, and then you draw the shadow, right, on the same grid. So you have your height or whatever gnomon you're using, and then you draw the shadow, right? And you just make a triangle, and all you do is measure that angle. So that gives you the angle of the sun's rays. And on the equinox, because of how the earth is positioned with respect to the sun, on the equinox, that angle is the same as your latitude. So again, and you can just measure that angle using a protractor. So you don't, I mean, again, this can be done with 6th standard, 7th standard, 8th standard students. And yeah. There's also a little calculation that you can do, and this might be a bit more advanced. So this is maybe something that you want to do with 8th, 9th standard students, about longitude, right? So as we talked about earlier, your longitude, you can also calculate it if you know what time local noon is. Given that you know what the central line is. So there's a little small exercise that you can do where you just need to do one measurement on the equinox, and you can calculate both latitude and longitude. Like, you don't need Google Maps. So and so the other thing that is special about this is this can be done anywhere in the world, right? So you don't have to be at the equator, you don't have to be in the tropics. Anywhere in the world on the equinox, you can calculate your latitude and longitude. So that's what the activity kind of goes through. Alok, do you want to add something about longitude? I think there's a
I think I covered that calculation. So the calculation Varun is talking about, it's so suppose you had two friends measuring the least shadow time. So the time difference, if you note down the time is in IST. So if say they are 1 hour apart, the longitude difference is exactly 15 degrees, and the same ratio and proportion you can find out to find the difference in longitude. So that calculation is very easy. It's just a matter of ratio and proportion.
सो जैसे अगर इसकी बात करें हम लोग, आलोक और वरुणी, जैसे आपने कई सारी चीजें इसमें बताई कि किस तरीके से सन जो है स्काई में आता है, और अलग अलग तरह की टर्म्स और टर्मिनोलॉजी इसमें हम लोग यूज कर रहे हैं. इवन इसके ऑब्जर्वेशन नहीं होते हैं. मतलब जैसे आपने भी कहा कि नाउ डेज वी आर नॉट सीइंग सनराइज एंड सनसेट, वी आर नॉट लुकिंग एट सन एनी मोर. तो इन चीजों को विजुअलाइज करना एक बहुत मुश्किल होता है. तो आपने कुछ संदर्भ भी बताया कि भाई कहाँ कहाँ पर जाकर हम इसको थोड़ा सा और जान सकते हैं, समझ सकते हैं. एंड यू मेंशन अबाउट जीरो शैडो डे ऐप, एंड थोड़ा आप इसके बारे में बताएंगे, मीन्स व्हाट दिस एप्लीकेशन एंड हाउ टीचर एंड स्टूडेंट्स कैन यूज दिस एप्लीकेशन.
मैं आपको एक एंड्रॉइड ऐप शेयर कर रहा हूँ. आई एम शेयरिंग दिस स्क्रीन राइट नाउ. सो दिस इज द जीरो शैडो डे ऐप. ये एक ऐप है आई हैव मेड इन कोलैबोरेशन विद ASI POEC. So this app, you can say it is a de facto resource app for daytime astronomy. So zero shadow day एक coordinated activity हम all over India try करते हैं उसको organize कराने के लिए. So this app is made with lot of content and a lot of resources as a ready reckoner and as a interactive tool. So first of all, you can download it from Play Store. I think we'll share the link with you. Free to download from Play Store. It's only for Android. From Android you can download, and once you give the permission for location, then you can also change the city and set it to any other city. For example, I'll just change the city to Mumbai, and all the data and calculation will be for Mumbai now. So once you do that, so there are many different things that you can see. One is local noon. So if you want to cheat and just directly know the local noon timing for your place, you can do that. So for Mumbai on January 11th, you can see the local noon timing, right? So there are other things also. For example, as I was mentioning about equation of time, because of the change, because of the longitude, the difference from 12 o'clock is 38 minutes, and because of equation of time, it's 7 minutes. See, I can change the dates. I'm using the arrows right here, clicking on it. You can do that on your phone right now. So I'm changing the days, and you can see how the time is changing, local noon time is changing, as well as the different components are changing. The blue bar, that is the longitude, that will not change. The equation of time will change. So I'll leave it at that. I'll cover this visualization part. This will be very helpful. So all the things we were discussing, it's very difficult to conceptualize and visualize where the sun is and what exactly is happening throughout the year. So this is like a third-person view of the whole universe. So you can see the path of the sun from outside of the universe. Obviously, physically this is not possible, but you can see that there is a brown sort of a rod on our pneumon in between. So, and its shadow. So for today, let me change the time. So you can scroll around and view this from any other angle. That is first thing you can do. I'll scroll this time bar. So as you can see, when I change the time, for this particular day, you can see how the sun is moving. And let me change the orientation. This will be a lot better. So along this orange line, you can see that the sun will rise and set. So this is how this sun is moving for this particular day. Now, if you want to see how this path will change throughout the year, I just need to press on this button. Now you can see this is Uttarayan, this is Dakshinayan. And you can see how the sun's path for the day is changing. You can do that, play around with different days, different time, and in fact, you can change the latitude as well. How changing the latitude will affect this path of the sun. I'll just change the latitude, and you can see how this is rotating. It's very difficult to take in it all at once. You can play around at your own time and come back to it to refer to any concept. So one more thing I think I mentioned before that I'll show you how the rising and setting point is changing, right? So just look at the orange line. I think you can see the cursor as well. See the cursor here. The rising point is south of east, right? So when I change the date, this rising point is yeah. So when I change the date, this rising point and setting point will change accordingly. And now you see the part of orange circle above the ground is more. This is the reason why days get longer and days get shorter. That you can try to visualize using this. What does it mean for days to get longer, and how it relates to Uttarayan and Dakshinayan. The other lines you see here are, the blue one is for winter solstice. So on winter solstice, the shortest day, the sun's path will be on this line. The white line, if you see closely, it's exactly passing through east and west. That line corresponds to the sun's path on equinox, and so on. So there are many other small tools mentioned in this app as well. So I suggest you download this and you can play around with it to cover most of the concepts that we are discussing.
Alok, can you show the noon on any given day? So there are other activities. For example, in our snippets, I think we only ask you to find the local noon for that particular day. But there are a lot more
things you can observe. What you can do is take shadows every day on a single time. Suppose you fix your time at 12 in what you call noon. So there is a section called shadow lens. So this basically gives you a chart that it's basically pre-filled for that location and 1 meter pole height. So I'll just change the date and you can see how the shadow length that curve is changing. So that is sort of a ready reckoner. I think Varuni will want to say something more on this.
No, I just wanted you to show a few of the other things. So this is sort of what I was talking about with the minima. So this is this is April 4th or whatever. But on any given day, there is a minima, and that is your local noon. And maybe if you change the location, you can also show how this curve moves either left or right. So it only goes up and down. So basically, your shadow lengths change if you're in the same location, but at different times of the year, right? Your local noon is more or less the same. There's that thing about equation of time, which is some small difference. Don't worry too much about it. But your shadow length changes, but your local noon is more or less the same. But if you change your location, so this was from Mumbai. So I think maybe if you change it, can we change? So if you change it now to say Calcutta or Guwahati, yeah, you'll see that there's that whole curve shifts towards the left. So that means your local noon is earlier in Guwahati than it is in Mumbai. So there's a lot of things that I know that this might be a lot of information that we're kind of talking to you about, but this app is something where you can kind of slowly try to go through all of this and see how it works. And I think like Amol was saying, like, you feel free to email them. They'll get in touch with us, and we are happy to tell you more about it.
तो आगे के सवाल में जाने से पहले आलोक और वरुणी, जो हमारे व्यूअर्स हैं उनसे दो सवाल आए, उनको लेते हैं ना। जैसे सूरज जो है टोंक से है, राजस्थान का ये जिला है, वो जानना चाहते हैं एंगल ऑफ एलिवेशन क्या है। मतलब उन्होंने एंगल ऑफ एलिवेशन ही लिखा है, बट आई थिंक वो पूछना चाह रहे हैं कि एंगल ऑफ एलिवेशन से क्या हम लोग समझते हैं।
See, angle of elevation is simply the angle of any object from the horizon. Horizon मतलब क्षितिज को हॉरिजॉन्टल मान के किसी स्टार या किसी भी ऑब्जेक्ट की ऊंचाई को हम एल्टीट्यूड बोलते हैं। सो ट्रिग्नोमेट्री में भी देखा होगा, हाइट्स एंड डिस्टेंसेस, ये शायद एडवांस क्लासेस में आ गया है। सो यू मेजर द एल्टीट्यूड। देयर आर स्पेशल इनफैक्ट इंस्ट्रूमेंट्स आल्सो। सेक्सटेंट होता है which lets you measure the height in angle. So by height we mean the angle made by the top of that object with the horizon. And for the sun, obviously we can't use a sextant or any other instrument. The only way to measure angle of elevation for the sun is again going back to shadows.
तो ये शैडो से एंगल कैसे मेजर कर सकते हैं, थोड़ा इसके बारे में बताएंगे? मतलब किस तरीके से इसको थोड़ा
I think it's very simple. आप एक खंबा ले रहे हैं. I don't even need a slide for this. So sun की रेज यहाँ से आई, यहाँ पे shadow बनी. So this angle, these are vertically opposite angle. You just have to draw it on paper. If I have them, I can also draw it. But this angle is basically distance from zenith. Zenith है the topmost point, right? And the other angle in this triangle is basically the angle of elevation. It's simply a matter of drawing a triangle with your object, the shadow, and drawing it on paper. So the two angles, one is the distance of the sun from the zenith, and the other is the height from the horizon, the angle of elevation.
Varuni, you were saying something. I think you were unmuted.
Oh, no, I was going to just show this triangle again, which Alok has done. So, yeah.
Okay. There is another question from Vishwanath Gokte. He wanted to know how to determine the inclination and dip.
Inclination and dip of what? I don't understand the context of this.
I think maybe Alok, there are two different angles, right? The
terminology. I think the angles I measured about. I don't think they're called inclination. I think dip might be named in some context. But yeah, I think he's asking about the same two angles that I mentioned.
Okay. There is one more question from Amit Nautiyal. He's asking, क्या सूर्य की दक्षिणायन और उत्तरायण की प्रक्रिया हर देश में होती है?
It's a global phenomena. It's basically because of tilt of the earth. If the earth was not tilted, अगर झुकाव नहीं होता 23.5 डिग्री, तो उत्तरायण दक्षिणायन नहीं होता, and we would have seen the same path every year. As Earth, this is because of revolution, tilt of the earth and revolution of Earth around the sun. जैसे जैसे ये टेक्स्ट बुक इमेज आपको याद होगी, solstice, equinox, there are different points on the orbit of the earth. So this is observed everywhere, and in fact, because of this, if you know on North Pole and South Pole, दिन और रात जो होते हैं 6-6 महीने की होती है. So when the sun is in the upper half, उत्तरायण होने के बाद जब ऊपर ऊपरी हाफ में सूरज चला जाता है तो 6 महीने नॉर्थ पोल पर दिन रहता है. सिमिलरली उस समय साउथ पोल पे 6 महीने रात रहती है, एंड इट टेक्स सिमिलरली 6 months of night and vice versa. So it's a global phenomenon. Uttarayan Dakshinayan is observed, and the north and south motion of the sun is observed everywhere on Earth.
So I will just maybe I have a few slides that might help with this explanation. That I'll just share my screen and show, if that's okay.
So वरुणी, जस्ट मैं थोड़ा सा बताना चाहूँगा जो हमें देख रहे सुन रहे हैं, जो हमारे दर्शक हैं. वेबिनार का समय वैसे 1 घंटे का है, लेकिन जिस तरीके से सवाल आ रहे हैं, वी आर एक्सटेंडिंग दिस टू हाफ एन आवर. सो आपके सवाल जारी रखिए, हम लोग बातचीत करेंगे, है ना. तो वरुणी, यू कैन गो अहेड, है ना.
So I'll just a few slides that might help with what Alok was just saying. So you can see my screen. Yeah. Okay. So basically, what Alok was talking about is, so this is, can you see? Yeah. So you can. So this is the tilt that is at 23.5, and this is the sun in the middle, and the Earth is going around it, right? And so this is the winter solstice. So in the winter, the southern hemisphere is sort of pointed towards the sun. And in the summer, so the June solstice, the northern hemisphere, which is where we are pointed towards the sun. So this is also in some sense where we get our seasons from. I think there was a question on the chat about opposite seasons in the northern and southern hemisphere. So this might help you understand that. So in December, the southern hemisphere is pointed towards the sun. So they have summer, we have winter. And during the June solstice, which the northern hemisphere where we are is pointed towards the sun. So we have summer, they have winter. So yeah, thanks for that question. It's very related to how the sun moves around. So this is just a few. So what happens is basically, this is your winter where the southern hemisphere is pointed towards. This is your summer where the northern hemisphere is pointed towards. And what happens is your Uttarayan, Dakshinayan is the sun's rays either coming from the south here in December and here in June from the north. And somewhere in between, it's exactly in the middle. So that in between is your equinox. And on the equinox, the sun's rays are perpendicular to the equator, at the equator, if that makes. Yeah. So I'll just, so this is, I think, what Alok was trying to also say. This is another, there are a couple of different ways, whatever makes it easier for you to visualize. So this is the other thing. So this is again addressing this question of, हर देश में होता है. हाँ, हर देश में होता है. All over the world this happens. So this is the earth, and wherever you are, you will see the sun moving from north to south and back. The interesting thing is that the zero shadow only happens in the tropics, but the sun movement happens all over the world. Yeah. This is again another way of seeing it. So this is similar to the visualization that Alok showed, where this is the arc of the sun during December, and then the arc moves. I think that's all I have. Yeah, that's all I have here. Just, yeah. I'll stop sharing now. I hope that helped with some of the visualization. It does take a little while to get in. So.
नो इट डज हेल्प वरुणी, क्योंकि इस तरीके के जो ऑब्जर्वेशन होते हैं, जैसे मैंने पहले भी कहा कि हमारे डे टू डे लाइफ में हमने ऑब्जर्वेशन करते नहीं है इस ऑब्जेक्टिव को ध्यान में रखते हुए, तो इस तरीके के विजुअलाइजेशन हेल्प ही करते हैं। जैसे आलोक और आप बता रहे थे कि जीरो शैडो डे ऐप, आई थिंक वो जो एक आर्क जो सन की जो पाथ की दिखाई दे रही थी इक्वेटर के नॉर्थ में और इक्वेटर के साउथ में, वो क्लियरली बता देता है कि नॉर्दर्न मतलब नॉर्थ में जब सन आता है, उत्तरायण में जब होता है, समर जब हमारे यहाँ पर होता है भारत में, तो वो इतना लंबे समय तक क्यों दिखता है, क्योंकि उसका वो पाथ जो है वो बिल्कुल विजुअलाइज हो पा रहा है कि इतना लंबा पाथ उसको चल के आना है पूरे आकाश में। तो इस तरह के विजुअलाइजेशन हेल्प ही करते हैं। एक एक सवाल और था, जैसे कि एप्लीकेशन के ऊपर हम लोग बात कर रहे थे, तो हालांकि उस सवाल पे मैं वापस जाऊंगा, लेकिन एक और सवाल जो हमारे दर्शक है वो पूछ रहे हैं हमसे कि जो जिस तरीके से हम लोग कहते हैं कि प्रेडिक्शन जो करते हैं सनराइज का, नून का, सनसेट का, तो अखबारों में भी आता है, लेकिन इस तरीके का प्रेडिक्शन पहले भी किया जाता था। जैसे कि अब मतलब पंचांग अगर जिसे हम कहेंगे, तो मतलब ये इतना एक्यूरेट कैसे होता है, और पर्टिकुलर लोकेशन के लिए क्या ये एक सही टूल है सनराइज और सनसेट को जानने का?
आई थिंक द क्वेश्चन इज इन जनरल पंचांग के बारे में। तो पंचांग जो है हमारा ट्रेडिशनल मेथड रहा है टाइम कीपिंग का। सो देर आर डिफरेंसेस। देखिए हमारे हिंदू पंचांग में जो है टाइम लूनर को फॉलो करता है। बेसिकली जैसे मैंने बताया था, तिथि जो है दैट ट्रैक्स द फेज ऑफ द मून। तो आज प्रथमा, द्वितीया, पूर्णिमा, अमावस्या जो भी होगी, इट्स बेस्ड ऑन द फेज ऑफ द मून। जो ग्रेगोरियन हम फॉलो कर रहे हैं दैट इज सोलर, क्योंकि दैट इज ऑल्सो आर्बिट्ररी, क्योंकि 29, 30, 31 जो ये दिन बांटे गए हैं, इट्स देयर इज नो एस्ट्रोनॉमिकल बेसिस फॉर दैट। जो हिंदू पंचांग में आर्यभट्ट के टाइम और उससे भी पहले जो साइंटिस्ट कहिए उस समय के, दे डिवाइस मेथड्स टू कीप ट्रैक ऑफ टाइम। तो बेसिकली सन और मून के जो स्काई में उन्होंने ऑब्जर्व किया, उन्होंने टाइम पीरियड निकाला। बेस्ड ऑन दैट दे मेड सम टेबल्स। जो आर्यभट्टिया में शायद सूर्य सिद्धांत और ये सारे एक एस्ट्रोनॉमिकल मॉडल ही है, ऑल्दो क्रूड फॉर देयर टाइम, जो मैन्युअली देख के उन्होंने पोजीशंस ट्रैक की। दे मेड मॉडल्स, यूजिंग दैट दे मेड टेबल्स व्हिच वर यूज्ड टू मेक पंचांग फॉर लोकेशन। सो पंचांग, वन मोर थिंग टू पॉइंट आउट इज पंचांग इज यूनिक फॉर एवरी लोकेशन। सो हर लोकेशन का पंचांग अलग है। हिंदू पंचांग में जो दिन की शुरुआत होती है सूर्योदय से होती है। सूर्योदय हर जगह का अलग होता है, इसलिए यू वुड सी कि हर जगह के अलग अलग पंचांग छपते हैं। राजस्थान में लोकल पंचांग अलग होगा, उत्तर प्रदेश में लोकल अलग होगा। So they have to be calculated for every other location. So one more thing I think asked is it a better tool for calibrating time? So the answer is other way around. Panchangs are basically tools made by us to keep track of time. जो आर्यभट्ट और पहले से सिद्धांत दास बने थे, they were crude. Now we have a more precise model of how the sun and the moon moves. अब नासा के जो मॉडल्स है, they predict the position of the moon and the sun and in fact even the planets to arc second accuracy. तो उसी की वजह से हम नासा और इसरो जो है मार्स और मंगलयान जैसे मिशन भेज पाते हैं कि एक एक मीटर की एक्यूरेसी तक हम उनकी पोजीशन को ट्रैक करते हैं। Obviously that is not needed for Panchang, but yeah, the idea is the same. It's basically a scientific model of how the things, the planet, sun and moon, all these things are moving.
हाँ, तो जैसे एक्चुअली मैंने नाम नहीं बताया जिन्होंने ये पूछा था, उनका नाम है विश्वनाथ गोगटे। उन्होंने शायद ऊपर से ही सवाल पूछ लिया था जो हम मिस कर गए थे, तो इसलिए मैंने उसको लिया उस सवाल को। तो जैसे मेरा एक सवाल ये था कि जैसे उस विजुअलाइजेशन में हम लोग देख रहे थे जो आपने दिखाया हमें कि एक तो मुंबई हम लोगों ने लिया था जो कि वेस्ट में आता है, और एक कलकत्ता लिया था। तो जो लोकल नून का जो टाइम है वो पहले आया और यहाँ पर बाद में आया। जो एक विजुअलाइज हो पाया। ये साउथ और सॉरी वेस्ट और ईस्ट के दो लोकेशन है, लेकिन क्या ये लोकल नून का जो टाइम है ये नॉर्थ और साउथ में, साउथ के लिए भी सेम रहेगा या चेंज हो जाएगा, जैसे दिल्ली या कोई हम लोग चेन्नई या बैंगलोर जैसा कोई शहर में?
I'll answer this in short. Same रहेगा, same longitude will have the same local route. And in fact इसका एक बहुत ही अच्छा यूज है जो आप एक्सपेरिमेंट में कर सकते हैं. एराटोस्थेनेस करके एक आई थिंक 2200 years ago ग्रीक साइंटिस्ट थे. He used the same local loon concept to measure the circumference of Earth. What he did was दो different locations, Syene I think in Egypt और ग्रीस में एक ही दिन पे शॉर्टेस्ट शैडो को ऑब्जर्व किया. साइन जो कि ट्रॉपिक ऑफ कैंसर के पास में, आई थिंक देयर वाज जीरो शैडो डे एट दैट टाइम, एंड ऑन द सेम लॉन्गिट्यूड, थोड़ा अप्रोक्सीमेटली लॉन्गिट्यूड डिफरेंट था बट ही वेंट एग्जैक्टली नॉर्थ, और उसी ग्रीस वाली लोकेशन में उसका फ्रेंड था. ही आस्क्ड him to measure the what angle did the sun make at local noon time, and that angle was 7 degree. So basically it was simply a matter of extrapolating it कि अर्थ का कर्वेचर जो है यहाँ सेम लॉन्गिट्यूड पे ट्रेवल करके 7 डिग्री है. आई थिंक वट एवर द डिस्टेंस वॉज जस्ट एक्सटेंडेड टू 360 डिग्री. सिंपल रेशियो एंड प्रोपोर्शन से इवन अ स्कूल स्टूडेंट कैन कैलकुलेट द सर्कमफ्रेंस ऑफ दैट. सो दिस इज समथिंग you all everyone can do. You need two people on the same longitude far away, and they can make the local measurement, and they can calculate the circumference of the earth using only these measurements.
तो एक और सवाल मेरा ये था, जैसे वरुणी आप बता सकते हैं कि आपने जब ये बताया था कि इक्विनॉक्स पे हम लोग जैसे कुछ हम लोगों ने जो गतिविधि की है वो इक्विनॉक्स पे हम लोग कर सकते हैं, आपका लोकेशन कोई भी हो. तो इक्विनॉक्स जो है ये स्पेशल 2 डे है, 23 मार्च एंड 21 सितंबर. तो बट यू ऑल्सो मेंशन अबाउट सोल्स्टाइसेस. तो सोल्स्टाइसेस को लेके कुछ ऐसे ऑब्जर्वेशन किए जा सकते हैं क्या सोल्स्टाइस डेज पे?
Yeah, so solstice, the solstices are, if you remember what I showed you earlier, so हमने, we started talking about this, which is that, if you ask students, where does the sun rise, everyone says sun rises in the east. Now, it's very nice to challenge them saying, are you sure? Like, did you check yesterday? Is it the same? At least in Chennai, I have had a lot of fun doing this with students. Because here we have the sea, and a lot of the students that come from fishing communities that live on the coast, they seem to know that no, the sun doesn't rise in the east every day. But if you go to these, schools inland, you normally get this, no, it rises in the east, forget about it. So on the equinox, the sun does rise in the east and set in the west, and only on the equinox, on the equinoxes. And this is true for any place in the world, right? So anywhere you are in the world, if you want to actually know what east is and what west is, you need to look at sunrise, sunset on the equinox. Now, on any other time of the year, as I showed you in that visualization, the path of the sun is moving, and the sun has its northernmost sunrise and northernmost sunset in the summer, right? On the solstice, the June solstice, and the southernmost sunrise and the southernmost sunset on the December solstice. So this is another experiment you can have children do. It's again very low sort of barrier. All you need to do is maybe once a week observe the sunrise and observe the sun, either the sunrise or the sunset. In fact, I will maybe share my screen again and give you a few other things that we can. So there is, I think Alok mentioned ASI POEC. So this is the public outreach wing of the Astronomical Society of India. Along with them, we have, I'll just wait for the screen to show up. Yeah. So this is, so the Android app that Alok talked about is there, but also we have, so in activities, you can look at, yeah, sorry, zero shadow day solstice. So there are these posters. So we had a drive for solstice some time back. So there are these posters that are there in many languages, not just English. We actually translated it into something like 23 languages or something. So they're all here and they're all freely downloadable. And so it gives you just like the snippet that we had about the what you can do on the equinox. This is what you can do on the solstice. So you can regularly see when sun rises and when the sun sets, and actually see the sun moving in the sky. And just to go back to kind of what we started with, I mean, these are very deep concepts of like this somehow what you're observing by just looking at sunrise and sunset at a regular basis. You are actually in some way observing the effect of the earth going around the sun, which I think there are very few other places we can actually observe this. So yeah, so the short answer is you can look at this webpage, ASIPOEC. I think it will be shared on the chat as well. Alok, do you want
Yeah.
to add something? There are a few other
I'll,
resources.
I'll recap the concept that we were discussing about Stonehenge, in particular Stonehenge. So just understand the basic idea of Stonehenge. It's just to track the rising and setting point of the sun. Once you get inside of that structure, there are pillars marked. So on special days like equinox, solstices, the markings, the whole idea of that structure is to track the rising and setting point of the sun for that location. So that's the special thing. That's why equinoxes and solstices were celebrated for thousands of years, because it was observable. The man like thousands of years ago was what he was saw every day was rising and setting of the sun, and that was a celebration, a cause of celebration of turning of the sun from south to north and vice versa. So this whole the activity that you would do for December solstice is what the core idea of Stonehenge is all about.
So actually, this kind of concepts and visualization and observation, it's very interesting to discuss with the student. But as a teacher, means previously you also shared your experiences with the student you are working. Even today you have done one activity. But as a teacher, when I see to these concepts and when I wanted to do with the student and make a plan, I find many challenges. Uh, so, are there any challenges you identified while doing these activities with the student? Specifically, if I mention my side, I find that it required a long time period observation, and to plan this it's very difficult. So, what kind of challenges and difficulty you find when you work with the students?
So this is absolutely true. I mean, I think, see, I've been, me and this other colleague Chaitanya, who actually some of the visualizations we had worked on together, along with some teachers from various parts of the country. And what has really helped us is kind of these discussions with teachers. I think some of them may have joined the YouTube session as well. So it always helps to have discussions with teachers, because at the end of the day, a lot, they are the ones doing it on the ground. So any sort of feedback in terms of this was too hard for my students to do, this was too easy, we are happy to get it, and you can get in touch with us either through iwonder or directly you can find us. But also to talk about these challenges of long-term measurements, it is true that maybe all students might not be interested to kind of measure every day. Some students might do it, some students might be, but I mean, at least as far as I sort of think about this, that's fine. I mean, this is something that if you're interested in it, I mean, not everyone has to become a scientist, not everyone has to do science. So if this is something that interests you as a student, that's great. I mean, you can get a lot of data very easily. with just doing kind of regular measurements. I think it also gives you a flavor of science, right? Because I think science is not just what's in the textbook, but also stuff. The actual data that you collect, it requires some amount of regularity, some amount of accuracy. The other thing that we have seen in a lot of student trials is that since the measurement is a repeated measurement, right? So yeah, we're asking the student to measure the shadow of the same stick 10 times or whatever, or every day, like for 2 weeks. One of the things that happens, which is very nice to see in students, is there's a lot of tinkering that happens. So initially they'll hold the stick and then they'll say, okay, no, it's not straight, let me make it straight. How do I make it stay in the same place? uh, and so this, these sort of tinkering things are very nice to see. I mean, you don't need a fancy equipment lab to tinker, right? A very simple setup like this, you have students trying a lot of things. I think one of the last trials that Chaitanya and I had done, so we had given them meter sticks, and the sticks were not, the ground was too hard or something, so it wasn't staying in the ground. So, first time they held it, then, they were like, no, no. Then we told them, maybe you want to hold it straight. So they took two water bottles and put the stick in between that to keep it straight. So there's a lot of this kind of innovation. I mean, you might think that this innovation is very basic, but it requires a student to kind of think about it, to engage with the problem, with the process. Okay, I have to measure it. I have to measure it every 10 minutes. I don't want to hold it straight every time. You know, so things like that, I think, while these are presented as difficulties, I think there are also actually advantages of this kind of setup, that the student, and there's nothing that's going to really hurt the student. So the student can do whatever they want with the stick, with the pencil. I mean, nothing. It's very there's no electricity, there's no current. I mean, you can do whatever you want. You're not going to hurt yourself. So I think that while you can think of it as difficulty, I think I see it as exploration for the student.
Yeah, true what you're saying. Because such kind of challenges create a space for discussion also with the students. I think that's what you are saying, and this kind of discussions are very much important than doing accurate setup. If they are doing mistake, then we can also have a discussion with them and find out why these errors or why this kind of setup is create a challenge. I think it's very true, Varuni. um, um, so, like we are discussing from last 1.5 hour, um, I think observation part is very much important in these activities. Um, and it is one of the most important skill in science also, doing observation and collecting data. Your two snippets are with the activities. We are also They are also emphasizing on this observation skill and taking a data and discussion on doing discussion on it. And I find this kind of topic, which is means daytime astronomy, this is not limited to the science topic, science subject, but it is also relevant in social science, geography area. There is a there is a theme in sixth class, Earth as a globe. I think what you have mentioned, it's covered in that theme also. Earth as a globe. How we find Earth as a globe means Earth is not a flat. Previously, people were assuming that Earth is a flat, but with the simple observations of sun motion and stars motion and their changing position, uh, we come to conclusion that Earth is a globe. And there are longitude. I think latitude and longitudes are very difficult to teach student because these are imaginary lines. uh, I wanted to ask a question: how latitude and longitude, what kind of points we can cover while doing this kind of activities? Because it's very difficult topic, which I find when I discuss with the teachers.
Yeah. So again, once they have a basic idea of geography, so there's a hierarchy of concepts that one needs to understand to master all these concepts. So as you mentioned, latitude and longitude. Then there is the tilt of the earth, the revolution of the earth, the rotation of the earth, and the Uttarayan and Dakshinan thing that we showed in that visualization. Tying all that in together involves a lot of like mathematical thing. And in fact, once you do these observations, so it's only a matter of drawing the triangle of object and all. So even without learning trigonometry, the student get an idea of it. So one small thing we do is that take the length of the moon, the object which we are taking shadows of, and the shadow length. So if you want to measure the angle, you just scale it down by a factor and draw it on a grid paper, as Varuni mentioned. So that teaches them about similar triangles, geometry, and even if they haven't learned of trigonometry, they would get an idea of how the angles and the sides are changing. So other than geography, I think geometry, mathematics, as in trigonometry, all these concepts are also strengthened by doing these sort of activities.
या थैंक यू आलोक. हम लोग पिछले कुछ 1-1.5 घंटे से कुछ मतलब बात जो कर रहे हैं उसमें कई सारे रेफरेंसेस आए हैं, जैसे कि एस्ट्रोनॉमिकल सोसाइटी ऑफ इंडिया और जीरो शैडो डे ऐप. इवन हमारे जो एक व्यूअर हैं उन्होंने भी पूछा कि भाई जो टूल्स है, जैसे स्टेलेरियम एक टूल है जो कि एक आई थिंक वो भी एक एप्लीकेशन ही है. इस तरह के टूल्स जो है उनका यूजफुलनेस क्या है, तो आप कुछ बता सकते कि किस तरह के टूल्स हम लोग इस्तेमाल कर सकते हैं, किन रेफरेंसेस को हम लोग यूटिलाइज कर सकते हैं इस तरह के जो प्रोजेक्ट हम लोग बच्चों के साथ करेंगे ऑब्जर्वेशन के लिए. तो आप बता सकते हैं कुछ इसके बारे में, आलोक और वरुणी.
So there are a few things. Some of them I showed you. So there's this ASI POEC website, which we will share in the chat box as well. वहाँ पे there are like for example Zero Shadow Day. This the app that Alok has been working on. It was made for one of these national kind of things that we did, where we wanted everyone to observe their shadow on their own Zero Shadow Day. So ASI POEC regularly has these sort of drives that they do, which are nationwide, including for solstice and equinox and things like that. So that is one place you can look. There's just to note, usually when we do these drives through the ASI POEC, the public outreach of the Astronomical Society, is that we also have the ability to share data. So we have a common kind of Google form where people can fill out, and then if there's enough data, we try and share it. So you can also take that data and do other things with it. This might be at a more advanced level, like Alok was saying, you can actually calculate the circumference of the Earth. So we do collect this kind of, centrally collect this data and put it out. So that is one thing for drives. The other thing, so that I think if someone can put it in the chat box, the ASI POEC web pages. The other thing that we have is, so there's this Vigyan Pratibha program, which is a program for middle school teachers. I mean, schools in general. So there is an activity that we have written about how to understand how the sun moves over the course of the year. So it has a story, and then it kind of has this graph where the students can kind of go through. How it's something that they do in 8th standard already, right? Like reading a graph, understanding a graph. So there's a lot of graph related activity in that unit, and also trying to understand how the sun moves. There is, I'll just give you one more. Oh yeah. I think they'll put the things in the chat. So that is the Where is My Shadow, which is an activity that is designed for school kids. That's the 8th grade student activity. The astronomy, the ASI POEC will be put up shortly. The last thing that I want to say is, I mean, this is not something new that, we have just we have recently started working on it, but there's a lot of people that have done, have done means from Greek times people have done, but even in India, people have recently been working on daytime astronomy activities. So there's this very nice book which was published, I think maybe 10 years ago or so, called Sun Earth Experiments, Daytime Astronomy. This is by Vivek Monterio and team who are in this NGO called Navnirmati. So they have some of the activities we have talked about, which is measuring shadows. They also have some of the activities that Alok mentioned very early on, which is how do you create an image of the sun. So don't ever look at the sun directly, etc. But there are ways where you can have a mirror that reflects the sun onto a screen. So some of those and you can actually follow sunspots and things like that. So some of those type of activities are also in that booklet. It's a really great booklet. I strongly suggest you look at it. They have a lot more activities about sun and daytime astronomy. The last question was about Stellarium, which I think I will let Alok take because I'm not very familiar with it.
Yeah, so Stellarium is basically it's sort of a mini planetarium for yourself. It's an app, and if you use it on a desktop, then it will show you how the sky will look for any location. So it's very helpful for nighttime astronomy. You'll get to know where the planets are and which star to find where. Now mobile versions are even more easier to use because of GPS. You don't even have to worry about setting your latitude, longitude, or whatever. Just open the app and you just point it to the sky and it will tell you the star. So Stellarium is more for nighttime astronomy. So the thing is, nighttime astronomy is like 95% of the astronomy, at least in Mindspace of current time. But the utility of daytime astronomy has been more, as I covered, about the timekeeping, sundials, and all. So now, since we have all this technology, we don't even bother to get the time using shadows. We just use our watches or mobiles. So daytime astronomy is somewhat relegated to backside. But yeah, as you would have seen in these activities, it is very interesting, and for students, it's a very good tool to increase their curiosity and get them to know what is exactly scientific method, different ways of observing and collaborating on their own. So that way, Stellarium and all. There are many other tools. So if you get into astronomy, you can contact us. We'll let you know. But there are very specialized things. So Stellarium is like a planetarium for yourself. You'll get to see which star and planets to find. Then daytime, I think the resources Varuni has just shared, the booklet, that will be very helpful because it is full of many different activities that you can do on your own on very low budget. I don't think it requires a lot of instruments for that.
Yeah, as you mentioned earlier, that it requires only stick and sun and flat surface. So it's not much required from this activity side in daytime astronomy especially. अरुणी और आलोक, जैसे आप दोनों भी मतलब आउटरीच एक्टिविटीज करते रहते हैं पब्लिक और स्टूडेंट्स के साथ, टीचर्स के साथ, और वैसे अगर देखा जाए एस्ट्रोनॉमी सब्जेक्ट ऐसा है जो कि ज़्यादा प्रोफेशनल्स का नहीं, एमेचर्स का ज़्यादा है हिस्टोरिकली अगर इसको देखें तो। और आप जिस तरीके से अलग अलग तरह के आउटरीच एक्टिविटीज़ करते हैं स्टूडेंट्स के साथ, जनरल पब्लिक के साथ, टीचर्स के साथ, आपने अपना एक एक्सपीरियंस भी बताया कि हमने कुछ टीचर्स का जो एक ग्रुप था उनको एक लोकेशन पे एक्टिविटी दी, कुछ एक लोकेशन पे हम लोग कर रहे थे, फिर डेटा कंपेयर किया। तो इस तरीके का एक आपका जो एक कोलैबोरेटिव एफर्ट जो होता है, जो एक पब्लिक आउटरीच का होता है, इसमें से किस तरीके का एक डेटा आप जनरेट करते हैं, या कुछ ऐसा कुछ आपका ऑब्जेक्टिव होता भी है क्या, और होता है तो फिर कैसे उस डेटा को आप देखते हैं? आई होप माय क्वेश्चन इज क्लियर.
Alok, why don't you just start off? I'll come in after you. You go ahead.
So, as Varuni said, the one direct observation, collaborative. In fact, I will give you first hand experience. So I am associated with this NGO in Bhopal. So Bhopal is in the same longitude as Bangalore. So Bangalore Planetarium Taralay has a very big celebration of Zero Shadow Day. I think it's on 24th of April. So every year they invite thousands of students there and do all these activities. Now what we do is being on the same longitude, every year we have a group of students at our center and they take these measurements. And we have video conferencing and we share the real-time shadow measurements with them. And the students there and our students as well use the same thing to do that Eratosthenes experiment to measure the circumference of the Earth. So that is one experiment. The other experiment is longitudinal difference. There are other, in fact, 3 or 4 different experiments that one can do in collaborative nature. And the best example is this circumference measurement. I think there is special missions going on that are like pairing different schools all over the world and doing that. Even if they are not on the same longitude, they are using some method to compensate for that. But other than that, there are other small things that you can use. Yeah, it's not very useful for small students by themselves. If you give all this data, all the observation points throughout India to him, he won't be able to make much of that. But yeah, like this, it's up to a teacher to pair up proper data point and then make sense of that for the student.
ये काफ़ी एक्साइटिंग है, मतलब आप जिस तरीके से बता रहे हैं ना, मुझे लगता है कि इस तरह की जो एक्टिविटीज़ होती है, जो अलग अलग लोकेशन के स्कूल से अलग अलग लोकेशन के ग्रुप्स को जोड़ के करने की, हालांकि इसमें नया कुछ नहीं खोजा जाएगा जैसे सरकमफरेंस ऑफ अर्थ है, लेकिन एक अपॉर्चुनिटी देता है उस ग्रुप को या टीचर्स को या स्टूडेंट्स को ये समझने के लिए कि ये कैसे किया जाता है, और एक विजुअलाइजेशन मुझे लगता है इससे काफ़ी मिलता है इस तरह के ऑब्जर्वेशन से और डेटा कंपैरिजन से। तो ये काफ़ी एक अच्छा एक्सपीरियंस यहाँ पर मुझे लगता है आपने शेयर किया। वरुणी, आप कुछ कहना चाहते हैं इसको लेके?
No, I think Alok covered it. जैसे आप बोल रहे हैं, इससे कुछ we're not going to find anything new, but for students, it's a nice way to experience, these concepts that are otherwise very, very abstract. Like, how do you know the sun is really going around, or a lot of those kind of questions, which this is a way to experience it and actually measure it and do some sort of scientific tinkering and measuring and data collecting. So.
तो मतलब ये काफ़ी एक्साइटिंग डिस्कशन आज का रहा आपके साथ कि कई सारी चीज़ों के बारे में जानने को मिला। हालांकि डे टाइम एस्ट्रोनॉमी एक अपने आप में मुझे लगता है और भी इसके ऊपर बात हो सकती है, और एक मुझे लगता है कि एस्ट्रोनॉमी एक सब्जेक्ट अगर मैं देखता हूँ तो स्कूलों में करिकुलम में हमेशा नेग्लेक्ट रहता है, और अगर टीचर्स डे टाइम एस्ट्रोनॉमी के पार्ट को भी अगर एक्सप्लोर करें अपने प्लान में, अपने सिलेबस में, तो मुझे लगता है कि जिस तरीके की विजुअलाइजेशन है जो आप आलोक और वरुणी कह रहे हैं कि भाई किसने देखा है कि सूरज घूमता है या धरती गोल है, तो ये सब एब्स्ट्रैक्ट कॉन्सेप्ट को लेके बच्चे ज़्यादा अच्छे तरीके से विजुअलाइज कर पाएंगे। तो मुझे लगता है कि आज का एक डिस्कशन ये जो डे टाइम एस्ट्रोनॉमी को लेकर रहा, मुझे काफ़ी पसंद आया, और जो हमारे जो व्यूअर्स हमारे साथ जुड़े थे, विश्वनाथ गोगटे, राकेश मिश्रा, इन्होंने भी कहा है कि भाई ये काफ़ी अच्छा इंफॉर्मेटिव और इंटरेस्टिंग एक डिस्कशन रहा है हमारा, और लोग मुझे लगता है कि आज के डिस्कशन से आप लोगों से और भी जानना चाहेंगे। हालांकि हमारे पास अभी समय जो है काफ़ी हम लोग आगे बढ़ चुके हैं, लेकिन अगर आप मतलब जो लोग हमें सुन रहे हैं उनके अगर कोई सवाल अगर होंगे तो आप हमें भेज सकते हैं, आपके सवाल आप हमें ईमेल कर सकते हैं। हमारा जो ईमेल है iwonder@apu.edu.in पर आप भेज सकते हैं। हम वरुणी और आलोक तक आपके जो सवाल है पहुंचाएंगे, और उनके जवाब भी आप तक पहुंचाने की हम लोग की पूरी कोशिश रहेगी। तो आलोक और वरुणी, आप दोनों को धन्यवाद आज के संवाद में शामिल होने के लिए।
Thank you for giving us the opportunity to interact with all the readers. Thanks.
Yeah, thanks. Yeah, these discussions with teachers always help us kind of make these activities better. So, yeah, always happy to
Yes.
talk to teachers.
तो आलोक और वरुणी, अभी हम लोग वेबिनार को यहीं पे रोकेंगे और लोगों से विदा लेंगे। लेकिन हमारा अगला जो वेबिनार होगा आई वंडर का, वो होगा 8 फरवरी को। और अगर आपने सब्सक्राइब किया है तो आपके पास इसकी अपडेट आएगी। अगर आपने सब्सक्राइब अभी नहीं किया तो प्लीज़ इसको सब्सक्राइब करिए। इस चैनल को भी आप सब्सक्राइब कीजिए, अजीम प्रेमजी यूनिवर्सिटी। तो यहाँ पर होने वाले जो वेबिनार से उसकी एक अपडेट आप तक पहुँचती रहेगी। तो इतना कहकर मैं आप सभी से विदा लेता हूँ। धन्यवाद, और हम लोग यहीं रुकते हैं। थैंक यू।